Hello and good morning to everyone. My name is Martin. Let's start to our group presentation. So firstly, we come to the part of introduction. According to the definition of mechanism of the machine, it refers to the study of how an object moves when it is subject to the action of force, including some unique situations like an object is in a stationary condition. The mechanism of machines can be divided into three disciplines, which are statics, kinematics, and kinetics. Statics refers to the force operating on and in a body at rest. Kinematics describes the potential motion of a body or system of bodies. And kinetics explains the motion that will take place in a certain scenario. So in our group case study, we are ordered to focus on the gym equipment which obeys the rules of the mechanism of machine. Among them, finally we choose cable machine and dumbbell. They cover the topics of power, transmission, and friction and wear.
Hi, my name is Ong Kang Nan and I will present about the background of case study. So the first case study is cable machine. In a pulley system, the friction between the belt or the cable and the surface in contact is being applied to keep the pulley from slipping relative to the belt. Now assume that you are a designer of the cable machine, calculate the coefficient of friction of each type of cable and determine the most suitable type of material for the cable. The following information and data are obtained from the experiment with the gun hampered TM220 belt drive and belt friction machine. The second case study is about dumbbell. In general, a spin-lock dumbbell collar are one of the safer methods for holding weight plate in place on a dumbbell. However, they aren't the tightest method, but they will definitely do a good job of stopping plate from falling off during an exercise. Now assume that you want to buy a set of dumbbell for home workout. Determine which dumbbell is safer, plastic or steel dumbbell with the following condition.
In the case study of cable machine, power transmission occurs through the flat belt drive because it has an efficiency of over 99%. To choose the most suitable material for making the cable, we need to determine the material that has the highest coefficient of friction. To calculate it, we need to rearrange the formula of tension ratio and finally we can get mu equal to 1 over theta times long times T1 over T2, which theta refers to the angle of contact in the radian, T1 refers to the tension on the tight side, and T2 is the tension on the slack side. In the case study of dumbbell, we need to determine the greatest torque needed to unscrew it so that it will not lose easily when used. Since the screw thread is essentially a spiral inclined plane, we compare the issue to a broadsiding on an inclined plane to better comprehend it. As everyone knows, the coefficient of friction is defined as mu equal to F over R, where F refers to the force parallel to the surface and R is the force normal to the surface as shown in figure. After deriving it, and we can get limiting angle equal to tangent minus 1 mu. Next, we are required to calculate the screw angle, which it is equal to tangent minus 1 P over pi D, where P is pitch and D is diameter. Using both angles above, force required is equal to weight tangent screw minus limiting angle, and the torque is equal to force times diameter over 2.
For the first case study, we use tension ratio formula to find the coefficient of friction, and after that we substitute all the information and data given and calculate the coefficient of friction of each type of rope. For the second case study, we need to first find the limiting angle, and second find the screw angle, and third we find the force applied to the screw, and lastly we find the torque applied to the screw. So this same goes for the steel dumbbell to find the torque applied to the screw. That's all from me, thank you.
Selamat sejahtera and hi, my name is Junlin Jaji. I will be presenting the discussion part of this project. For case study 1, the topic cover is chapter 2, power transfer. The requirement of this case study is to identify the most suitable material for the cable on the cable machine. As we all know, friction is important in pulley. As you can imagine, without friction between the cable and the pulley, the cable will just slip over the pulley instead of moving along with it. So in this case, we would just choose the material with the highest coefficient of friction. In order to calculate the coefficient of friction for each material, an apparatus named the Gunn-Hamburg TM220 is used. According to the calculation, the braided steel wire rope had the highest coefficient of friction, which is 0.15, followed by nylon rope and polypropylene fiber rope. For this reason, braided steel wire rope was selected. Next, for case study 2, the topic cover is chapter 4, friction and wear. The requirement of this case study is to determine which dumbbell is safer, plastic or steel dumbbell. The lower part of the spin lock collar and bar while holding the dumbbell in a vertical position is the only situation considered in this case study. It means that this is the scope of our case study. We are not considering the dumbbell in horizontal position. Instead, we are considering the lower part of the dumbbell in vertical position only. To avoid the weight from falling off, the torque needed to unscrew the spin lock collar should be as high as possible. And according to the calculation, the torque needed to unscrew the steel spin lock collar is 0.2471 Nm, which is higher than the plastic spin lock collar. Due to this reason, steel dumbbell is a safer choice than a plastic dumbbell. Lastly, I will be presenting conclusion for case study 1. As I mentioned just now, braided steel wire rope is selected due to it has the highest coefficient of friction. In fact, braided steel wire rope is the type of cable that is widely used in commercialized cable machine. This is because, apart from the high coefficient of friction, it also had the robust strength of the steel core wire rope, which give a promising lifespan to the cable. And I would just like to mention the knowledge covered in this study case can also be used in determining how many times the belt or the rope must be wrapped around a curved surface to prevent it from slipping. For case study 2, we conclude that steel dumbbell is considered a safer choice than a plastic dumbbell. This is due to the torque needed to unscrew the steel spin lock collar is higher than the torque needed to unscrew the plastic spin lock collar. Same, I would like to mention the knowledge covered in this study case is important in automated machinery. By calculating the force and torque, we can control the exact force needed for lifting or lower a specific load and reduce the wear and tear of the screw jack. That's all from our group. Thank you for lending us your ears.